Uh, okay, so we continue the lesson predicates and quantifiers, but I want to start with an example. Uh, so let me read the example, at least the first part of it. The universe of this course, let the universe of this course be the set of all humans, assuming that humans are defined, okay? The following predicates are defined. So this is a little bit of deviation, okay? So AX, X is an artist. So for example, BX, X is a book lover. So here, in principle, I'm violating myself a little bit because my goal is my objective is different here. So in principle, this is not a good predicate, yes? Because if I replace X with, for example, Bobak, Bobak is a book lover. So yes, I cannot say what is the meaning of being a book lover. So anyway, or Bobak is creative. Yeah, so these kinds of sentences we should avoid in mathematics. But because my objective here is different, forget about that nuances. Okay, so consider that these are predicates, meaning that if you replace X with any element from the set of humans, then it becomes a proposition. Okay, even though technically speaking it is not. Okay, so remember these. And now I want you to, based on these, I will write them on the board and then I want you to symbolize these sentences. Okay, so this is important to have this skill. So let me write the sentences here. So I have written them here. So this should be displays. I have written display there. So consider these, and I want you to write these sentences using quantifiers and things like these are English sentences. I want you to start writing them down yourself. Okay? So be careful. Sometimes it is not as easy as you might think. Okay? Okay, do you think you are ready? Should we go through it? Yes, should we go through it? Okay, so all book lovers are creative. So what do you say? I don't know why I started with this one. Probably it's a little bit tricky one. How do you write all book lovers are creative? By the way, this is plain English. You really understand what does it mean? It means what? Exactly. Yes. So this implication comes in. So this means that if you are all book lovers are creative. So it means that for every X, this means for every human, because X here the universe of this course is the set of humans. So for every human, if that human is a book lover, then that person, that human is also creative. Yes. So this you need to understand that what should I write? If book lover, then creative. Do you agree with the first one? So that is how you write the first sentence. So you have to use the implication here. Okay, what about the second one? So the second one tells you some artists are also book lovers. What does it mean? There exists an X
for which AX implies BX.
Some artists are also book lovers. Yes?
There exists an X such that AX and BX.
AX and BX. Yes? There exists a human who is artist and book lover. There is no implication going on here. Is that right? So be careful. They exist. That's good to know about how to write them. Understandable? No doubts. Okay, number 3. If all artists are creative, then some of them display their work. Okay, so what should I write? Yes?
I would say for all X, AX and CX.
If all artists are creative, what should I write? For all? So tell me, and then we...
X and then AX and CX.
Like this? There exists x such that dx. So how many of you agree with this one? If all artists are creative.
That should be an implication.
This one? Yes. I would say that should also be an implication.
If all artists are.
Yes?
Yeah, because it's not all artists and creators are.
So how should I fix this? For all x, if x is an artist, then that person is also creative. Then you have this.
So if it was.
So this means that this is your assumption. This assumption tells you that if you have artists, every artist is creative. That's the meaning. If every artist is creative, then there exists there exists a person which display the work, but that is not correct.
Yeah.
Because this again is chosen from the universe, everyone. So you should make it an artist. So how should I write this? There exists.
Oh, yes. There exists an X.
There exists
an
an artist.
Such that they display their work.
Yes. There exists a human who is artist and displays the work. So it is tricky. It's not that easy. You have to be careful. Yes. So this tells you that. This grants you that every artist is creative, which is a good assumption. I mean, reasonable assumption. If every artist is creative, then there exists an artist that displays the work. Yes. If you don't write this, this means there exists a human that displays the work. Yes, which is different from that. Because here the word some refers to some of the artists. Okay?
But I mean, the artists are also human, so there is still a human that does display their work.
No, but that is not this sentence. Yes?
Yeah, I get it. Then it would be then some person in the world displays their work.
Yeah, that is not that sentence. That's the whole point. Yes. Yeah, please correct me because sometimes I go back and forth between a lot of gadgets here. I'm also confused. But I think this is the correct translation of this. Yes or no? Do you agree? Okay. So now, some book lovers and artists are creative. Usually in English, that is my understanding of English because English is not my native language. But when I read this, some book lovers are creative and some artists are creative. This is the way I interpret this English sentence. I don't know. As I told you, English is not my native language. But don't you feel this is the meaning of this sentence, yes? Some book lovers and artists are creative. So you can say, for me, this sentence means some book lovers are creative and some artists are creative. This is what I understand from this sentence, if they don't emphasize anything else.
So you interpret it as like there's at least one of each.
Yes.
That are creative.
Yeah.
Okay.
Yes. So I don't know. That is the interpretation. So in that interpretation, what do you write this then? There exists what? X, which is a book lover and creative, and there exists. I can use the same letter, or if you want, you can change it because these are dummy variables. So I can write Y. It doesn't matter. And then artist and creative. Of course, later we will talk about distributivity laws and things like that for quantifiers. But this is what I interpret. I hope that you agree with me as well. So number 5, all artists are creative and some of them display their work. So this is very similar to the previous case, yes? So, yeah.
So, I mean, it's just for all x, ax implies cx.
For all x, what? Ax implies cx. It means that for every human, if that human is an artist, then he is creative. Okay? And
there exists
some of them, so there exists x of which group?
an artist.
some of them, it means some artists. There exists an X which is both an artist and display the work. Here you can also change the variable to another name, but it is not necessary in principle. Imagine like this, because at the end there is no dependence to any variable here. So it is without variables, yes? Because that is only, you have only one bound variable, so it means at the end there is no variable left. So it doesn't matter if you write the same letter here, or as I did here, choose a different letter. So hopefully we agree with this one as well. What about the last one? None of the book lovers are artists.
For all x, there exists bx.
For all x,
Oh yeah, so for all x, bx implies not ax.
bx implies not
Ax.
ax. So for every human, if that human is a book lover, then that human is not an artist. So this means that none of the book lovers are artists. Is that understand? It's a little bit tricky, but do you understand that? Yes? Okay. So that's also a good way to write this down. So that was a good exercise, I would say. Do you agree? Okay.
So
Yes?
for number 3, if you just remove the if at the start of the sentence,
Yes.
then it's and.
All artists are creative. No, I should write and. So if I just remove if, and there is a then here, and if I change that then to and, then it becomes and, of course.
Yeah, but if you say and, then that middle condition would also become an and.
Yes, yes, yes.
But if you say all artists are creative,
Yeah.
and this implies that some of them display their work, it doesn't really make sense. But if you were to say that, would that still work?
Okay, so don't confuse me. If it doesn't make sense, let us skip that. Of course, you can think this is just. I just want to see that how you can symbolize English sentences. So as I told you before, in principle, these are not good examples of predicates. Okay, so now let us go to this example. Now, this is a little bit better one. I want to have more than one quantifier here. So let the universe of this course for both variables be the set of the students in a technique class. So for example, you consider technique 21, for example. Let us say that the universe of this course are those people. And define the following predicates. L, X, and Y. I am using a slightly different notation to remove the ambiguity in case you are confused. So L, X, and Y means X likes Y. S, X, and Y, X is smarter than Y. O, X, and Y means X is older than Y. Let us consider these. And then I want you to write these sentences again. Okay, so if you want, I think the things are clear, but if you don't mind, let me go back to the previous slide and write them down here for you so that you can have it in front of your eyes. So we have 3 of them. So L, X, and Y. X likes Y. What was the other one? S, X, and Y. X is smarter than Y. And then O, X, and Y. X is older than Y. Okay? So based on what you see here on the board, I want you to start symbolizing these sentences. John likes everyone. For example, when I say John, it means the name of one of the students in technique class is John. Yes, otherwise I'm not allowed to use it. Okay, so I want to wait for you again. Should we start? So let us see. The first one, John likes everyone. So here John means what? John is a member of this technique class. So John is neither a free variable, neither a bound variable. This is called a constant. John is one particular element from the universe of this course. If we have this scenario, that is called a constant. So John is a constant here. John likes everyone. So how should I write number 1? John likes everyone.
For all
For all,
X or Y, whatever. I chose Y percent.
no, for there are no two variables here.
Okay, well, for all
Yes.
X, yeah.
For all x, what?
J L parentheses J X. Or
John
write
likes
yeah.
everyone. Yes.
So
So John
X.
x. It's the first one. Do you agree? For every student from technique class, this is the case. John likes that person. So this means John likes everyone in the group. So someone likes everyone. So that's a kind person in the class that likes everyone. Yes. So how do you write that?
There exists an X.
Let me see if I'm recording. Yes. So there exists
An X.
an X.
So for all Y.
Yes, likes everyone for all Y.
Yeah. And then LXY.
XY or YX?
XY.
XY. So there is a student in that group, so that every student is liked by him or her. Yes. So that's number 2. So number 3, everyone likes John. So how should I write that? Everyone likes John means for all X, L what? X John. John is the constant here. So number 4, everyone likes someone.
For every X.
Everyone, for every X,
There exists a Y.
there exists a Y,
And then LXY.
LXY. Yes? Everyone likes someone. Okay, be careful about this. Is that the case? For everyone, this is important to understand. For everyone, no, so be careful, this is wrong. Isn't it?
So for everyone, there exists a person and a person.
And that is the trick here. So that is wrong, yes? Everyone likes someone. No, that's correct.
I mean,
No, that's correct. Sorry, that's correct. Everyone, for everyone, there is a person
And
that person likes him or her, or that is liked by that person. Yes. So everyone likes someone. Everyone likes someone who is smarter than them. So number 5. Everyone likes someone who is smarter than them.
for every X,
For every X,
there exists a Y.
there is a Y.
And S. I don't know. S.
Everyone likes someone.
So SYX. Or I mean.
SYX,
Yeah. And LXY.
something like that.
Yes. That's right.
If that's the case, I have to put a pair of brackets here then. Do you agree with this? Everyone likes someone who.
So for everyone, there exists a person who's smarter than them and who they like.
Yes. So for every person, there is another person, so that that person is smarter than him, and he likes that smarter person. Yes, that's the meaning. Do you agree? Okay. So number 6. So what's number 6? Everyone Claire likes is smarter than her.
So for all X.
For all X,
L Claire X, I guess.
Claire likes, so it becomes Claire X implies
that S X Claire.
X Claire, yes? Are you with me or not? Please correct me if I'm doing something wrong. Yes? So this means that from everyone, for everyone, if Claire likes that person is smarter than Claire. So in principle, yeah, if Claire likes someone, you can conclude that that person is smarter than Claire. Yes. Okay. So number 7. So David is also a constant here. So number 7. David is smarter than everyone who is older than him. So in principle, you can say David is a genius. Yes. David is smarter than everyone who is older than him. So how can I say that?
So for all x,
For all x,
OXD.
O x David, O x David.
Yeah, that implies that.
So this means that for every x, if x is older than David, then
That implies that S David X.
S David x. Yes. For every student in the class, if this is the case, that student is older than David, then David is smarter than X. Yes, that is what. So this implication, do you understand how to use the implication? Implication is not implemented in the sentence here. There is no if and then, but you have to understand it yourself. Okay, finally number 8. So let me write number 8 here. So number 8. Everyone is smarter than all those people who are older than them.
So for every X and every Y.
So everyone is smarter. So for every X and
Every Y.
every Y.
OYX.
Everyone is smarter than all those people who are older than them. If
OYX, I guess.
it doesn't matter here,
Yeah, exactly. Yeah, it's equivalent.
then
That implies that X1
Or YX.
what?
S.
S
YX.
YX. Yes. So for so this means that everyone is smarter than all those people who are older than them. Yes? Yes. If X is older than Y, then Y is smarter than X. Is that right? Yes? Understandable? Okay. So let me ask you something here. So let us talk a little bit here. Do you remember I also was a little bit confused here? So if I, here in this sentence, this was what? Number 4. So number 4 was everyone likes someone. What is the meaning of this sentence then? So what I'm doing, I am interchanging an existential quantifier with a universal quantifier. I just want you to understand that. Do you think that, so here, when I wanted to write for all X and for all Y, you understood there is no importance here which order I write them. Yes? But do you think here the order matters? Is there any difference between this sentence and that sentence?
Sure hope not.
No, there shouldn't be.
Which two sentences?
So this means that for all X, there exists a Y, so that X likes Y.
Yeah, I mean.
But this sentence says that there is a person, so that for every X, X likes Y. I want you to feel the difference. They are not equivalent.
So that means that.
This means that every person has someone to like. But this means that there is a person who is liked by everyone. So this is some kind of a leader. I don't know. For example, Mahatma Gandhi. I don't know. Mahatma Gandhi was liked by everyone. So Mahatma Gandhi is liked by everyone. This is not the same as that.
One also just says, yeah, sure.
But no, because.
So these two sentences are different.
Because in number 2, right?
So if you don't like this, let me give you another example. For all X, there exists a Y. Sorry, there exists a Y. So that let us take the universe of this course to be the real numbers. I'm asking you, this is a very delicate and subtle difference.
Okay, yeah, I get
So
it.
there exists a y for all x plus y equals to 0.
Yeah.
Okay? So I want you to say to the universe of this course is the set of real numbers. So this is a statement or not? Because these are bound variables and I have only two variables. So this is a proposition. That is also a proposition. So it is true or false. Is it true or false? This one or that one?
First one is true, second one is false.
Yes. So the first one is true. Yes. The second one is false. So it shows that if I interchange these two quantifiers, I will not get the same thing. Let us try to understand. What does this tell you? This tells you that every real number that I give you, you are able to give me another real number so that the sum of those numbers are 0. For example, if I give you 5, you can give me minus 5. If I give you a square root of 2, you can give me minus a square root of 2. So this statement is true. But this statement tells you there exists one y so that for every x, no matter which x plus that y is 0. Okay? So this is not true. Why is that? For example, do you think 5 is working for y? No, because if you tell me why 5 is that number, yes, it works for minus 5, but it does not work for any other number. So these two statements are not equivalent. So you are not allowed to blindly interchange the quantifiers if one of them is existential and the other one is universal. Yes? This is very important, by the way, because we want to talk in mathematical analysis later, and this is extremely important. Okay, so we cannot. But one of them implies the other one. Because when we say they are not equivalent, okay, it means that sometimes one of them is true, the other one is false. But do you think one of them will imply the other one if true?
If the first one is true, that will imply the second.
No, you see that this will not imply this because this is true. I will not be able to imply this. But what is the other way around? So let me write for all y. So there exists a y for all x, p, x, and y. And then I will also have for all x, there exists a y, p, x, and y. Regardless of which one is true or which one is false, do you agree that this will imply that?
Yeah.
If this is true, this one is also true. Not the other way around. So that is important. I want you to write it down somewhere. So this is the case. Why is that? It is not hard to understand. This tells you. So let us use the example of Mahatma Gandhi. Let us assume that Mahatma Gandhi is liked by every Indian. Of course, it is not true, but let us use this. Okay? So Mahatma Gandhi is liked by every Indian. Okay? Can I conclude that for every Indian, there is another Indian who likes that Indian?
Who they like.
Who they like, yes. And that one is Mahatma Gandhi again. Yes? So Mahatma Gandhi is also playing the role of this for this one. So this one, this tells you that there is one person. If I want to draw a diagram, so let me just try to draw a diagram for you. Okay, let me make it very simple. Okay, so let me take the technique class, including these three people. Only these three people. Okay, and then I have these diagrams A, B, and C here. A, B, and C here. Okay, so let us take this convention. When I draw this arrow, I mean A likes B. Okay? Okay. But can you draw a diagram for, I want you to feel the difference. I want you to draw a diagram for me for which this is true. So can you draw a diagram for which this is true? For example, so do you think if I draw the diagram like this, For this diagram, do you think this is true?
Yeah.
Yes, because every element here, every member, for every member, there is a person so that that person likes that person. Which, of course, in this case, everyone likes B. Yes? So do you think for this case, this is also true or not?
Yes.
For this diagram, this is also true. It means there is a person, everyone likes him. Which person is that? B. So this diagram, for this diagram, both of them are correct. Okay, but let me change the diagram to this. For example, let me just do that. Let me do that. Okay. For this diagram, do you think this is true or false?
That's true.
That's true again. Yes? Because every person likes one person at least. But what about this one?
No.
Is there a person who is liked by everyone? No. So this is false. This is true for this case, for this diagram. Yes? Understandable? So be careful. You are not allowed, but you can see that in this diagram. If I grant you this, for this diagram, if I grant you this, then automatically you can also grant this. This tells you that there is a person who is liked by everyone. So everyone likes at least one person. That is true, the same person. Yes? So here, be careful. For all x, there exists y is not equivalent to for all, this one is not the same. Be careful about not to make that mistake. But which one implies the other one? Not the other way around. Okay, so this is just as a remark, you can write it somewhere. And this is probably from the world of mathematics. It is extremely simple to understand that they are not equivalent, but this one will imply the other one. Yes, is that understandable? Okay, so what time is it? We are close to finish. Let me see if I have missed other things or not. But what about two universal quantifiers and two existential quantifiers? Do you think I can commute them?
Yeah.
So for all x, for all y, or for all y, for all x, and then for all, there exists x, there exists y, or there exists y, there exists x. So if I want you to read this, can you read this in plain English?
So everyone likes everyone?
Everyone likes everyone. Yes? Everyone likes everyone. So if I just interchange them, everyone is liked by everyone. But that's the same thing. Yes? So they are the same. So here, what about this one? So these are equivalent. And then what about this one?
Some people like some other people.
There is a person who likes some person. There is a person who is liked by some person. So they are the same. So it's important to know that if you have the same type of quantifiers, you can interchange them. But if one of them is universal, one of them is existential, then it is extremely important to understand that they are not equivalent, but one of them can imply the other one. The one starting with existential will imply the one starting with universal. Before finishing this lesson, let me just give you two more points and then we can finish. Sometimes in mathematics we have two other quantifiers, but we don't teach them formally here. One of them is the uniqueness quantifier and the other one is non-existential quantifier. For example, I say that there is exactly one number with this property, and sometimes I say there are no numbers with that property. Okay, so these two quantifiers are also in mathematics. Sometimes you can see them. The reason in logic we don't talk about them, why do you think we don't talk about them formally?
Because you can define them using the limits.
So let me write. This means there exists exactly one. So this exclamation mark means uniqueness. And if you want to write there is no, you can just do that. So there is no, okay? There is exactly one. So there is exactly one x p of x. So there is exactly one x such that p of x. There is no x such that p of x. This is called non-existential quantifier, and this is called uniqueness quantifier. We might use them, but we don't work with them in logic at least. The reason is, for example, let us start with this one. I don't need this quantifier because I can always write it in terms of the other quantifiers. So can you write this sentence?
For every p of x.
Be careful. I want to write this in a way that I do not use non-existential quantifier. What I'm allowed to use is other connectives and existential and universal quantifiers. Yes?
For every x, not px.
For every x, not px. Okay? So that is, so whenever you see this, you can take this as the definition. The definition of this non-existential quantifier is this. So this means there is no x such that p of x is true. It means for every x, not px. That's the mean. Okay, this one is a little bit harder to write. So if I want you to write this, how do you write this? There exists a unique x, px. Yes?
An x.
There exists an x, px, and
for all x.
exactly, thank you, for all x,
For all y.
for all y.
Where px and py
Very good.
implies that px is not equal to y.
X
For
is equal to y.
oh yeah.
Yes. Yes. Very good. So you can say this is the shorthand for this. Yes?
Oh yeah, not equal would just be there exists none.
No, you say that if this is the case that both px and py are true, then it means x is the same as y.
But if I had said x is not equal to y instead, then it would just be the non-existent or there exists
No,
none.
that would mean
Wouldn't it be equivalent to
a
that?
number can't equal itself for this to be true.
Just funny to think
I don't know. You are saying that if I just write this at the end,
Yeah.
then it means non-existence?
Yeah, but I
Yeah.
mean, it's just a neat.
No, but because you are emphasizing there exists.
I mean, it's
Yeah, exactly, but that's so it's contradictory. Just to write.
Or might be you say that I just dropped this one.
But then they have to be full, like statement.
I mean, you're just making an artificial.
No, let us not make things complicated.
Yeah,
Okay.
yeah.
Okay. So this is, you see that this is very useful because if you don't use this, every time you want to use this, you have to write all these things. Okay? But that is exactly the meaning. So that is why, even though later we might use these symbols, but essentially we don't need them. Do you remember? It is like what? Do you remember which one of these connectives are primary?
And not.
Yes? So you remember that actually every one of them can be defined only in terms of these two. But for computer, might be doesn't have any problems reading everything in terms of these two, but for humans, it is better to have more natural language, yes, so that we can talk about.
But you can use or instead of that.
We can, but if we assume the De Morgan's law. Yeah. So De Morgan's law, if you remember, P or Q can be written as not P and not Q. So in principle, if I have only not and, then I can also write or. Yes? Okay, so that is also good to know. Any questions? But I will probably to make another quiz. The quiz online now is based on the previous lessons before quantifiers and predicates. That is not hard, just review, okay? And then and that's also autocorrection, so it will automatically correct and I will design something for this one as well. Okay, so might be once a week for the summer is good, and then we can join probably next week for the new lesson. Okay, so I think two or three lessons at most we will go to logic, and then I want to go to set theory. So now what we learn here I want to use in set theory, and then probably in set theory, and then I will go to a little bit of group theory, field theory, and things like that from abstract algebra, so that we can come back to finally the basics of mathematical analysis in a rigorous way. Let us see how it goes. Okay, any questions? Yeah, so that's a good point to stop here. Thank you.